Hello everyone, welcome all of you to our YouTube channel. This is Rishikesh Kadam, and in this particular video we are going to create a fake news detection or classification project with end-to-end deployment. So if you are looking for a best project in case of NLP part, then you are at the right place. Now let's see what are the steps that we are going to perform in our project. Firstly, we are going to clean our dataset. I am going to use this dataset. This is the fake news detection or fake news dataset. It is actually a Kaggle competition, and we are going to use the same dataset which they have used in a Kaggle competition. So this is the dataset. It contains a label, or text. Text contain the news, and the label part contain it is an reliable news or unreliable. Reliable is specifically the news on which I can rely, or unreliable means I can't rely on that particular news. That is the fake news. So ideally, the label 1 is fake news and the label 0 is a true news, or we can say real news. So they have provided uh, trend.csv or test.csv. So we are going to use this trend.csv to train our model. So let's move on to the project part. You can download this dataset. I will share the link of this particular dataset in the video description. So for before downloading this particular dataset, you have to accept the rules and regulations of this particular competition, and then you can only download this dataset. Now let's move on to the project part. The second step is EDA. That is we are going to perform some exploratory data analysis. That is, we are going to gain some insights from our data with the help of some graphical visualization. After that, we are going to perform text preprocessing, which is the very important and major part of our project, because any model requires a clean data. So before going for the modeling part, we have to clean our text. Okay. The fourth step is very important, that is the creating a custom LSTM model. We are going to create a custom architecture of LSTM. We are going to train our data with the help of this LSTM model, and the last step is we are going to deploy this LSTM model. So these are the steps that we are going to perform in our project. So stay tuned till end of this video so that you will have in-depth understanding of how to create uh, fake news classification classifier and how to deploy it. Okay. First of all, let's create a file in which we are going to write our whole model training pipeline. So let's name it as a fake underscore news, and the extension of it is IPYNB. Okay. So this is our file. Firstly, let's import the basic required libraries, that is pandas. Import pandas as PD. Let's load our dataset. Data equals to PD dot read underscore CSV, and inside this we have to pass a path of that particular file. I have copied the same file trend.csv in the same directory, so I have to just pass the name of that particular file trend.csv, and again going to load the first 5 to 6 rows of that particular data set with the help of data.head. So let's run this. This is our data set. It contains id column. Second column is title of that particular news. Third is author of that particular news, and again text is the actual news, and lastly the label consists of two labels. First is 0 means it's a real news, and the 1 means it's a fake news, or we can say unrealistic news, or which the news which on which I can't rely. Okay. So firstly, we have to remove this id column because it does not add any value to our model training. So let's remove this id column. Data dot drop. We have to pass the column name. Column equals to the list of, okay, the list of that columns, but this time you have to just pass id because we are going to drop only one column, and also we have to pass access equals to 1. Okay, here you can see our id column is get removed. Now let's check is there any null value in our data set. For that we are going to write data dot is null. Uh, so I have to write here dot sum, so it will return all the count of that particular null values. The title column contains around 558 null values. Author column has around 1957 null values, and the text column has 39 null values. So let's drop these null values. For that we are going to use data dot drop na. So inside this we have to pass uh, the in place equals to true, because we are going to drop that particular null values from the original data set as well. So let's run this. Now let's load our data set again. So this is our clean data set. I think I have to pass here in place equals to true. That's why place equals to true. So it will, the id column will get removed from the original data set as well. Okay. So here you can see this is our clean data set. It does not contain any null value, and also the id column is also get removed. Let's check the class-wise data distribution of our news. So we'll check how many news belongs to the label 0 and how many news belongs to the label 1. So for that we are going to perform pandas operation, data of label equals to 0. I'm going to check length of the all news length. Okay. So 10,361 news belongs to the 0th label, that is real news. And let's check the how many news belongs to the label 1. So let's change it here. So 7,924 news belongs to the label 1. It is the fake news. Let's perform some exploratory data analysis to understand or to gain some insights from our data. So I'm going to mark down this EDA. It's an exploratory data analysis part. Analysis. Okay. So let's run this. We are going to import some basic required libraries for EDA part. Let's import matplotlib.pyplot as PLT, and the second library is cbound library. It's also a very important library for visualization part. Import cbound as SNS. Let's check the counts of news belongs to the specific class. Values underscore counts equals to data of label dot value underscore counts. Let's create a bar graph with the help of matplotlib and cbound. So first of all, let's define the figure size. plt.figure. Inside this we have to pass figure size. It is 8:6. We are going to create a bar plot with the help of SNS dot bar plot. Inside this we have to pass two arguments, that is x, which is values underscore count dot index, and the second is y, which is values underscore count dot values. Okay. So let's define the label, that is first of all let's define the title. Plt dot title. Let's write it as a data distribution of class wise data distribution. Class wise data distribution. Okay. Let's label our x axis plt dot x label as a category or the classes category, and y label is plt dot y label as a We can say count or frequency. Let's say count. Now we are going to do plt dot show. So I think function has no attribute index. Values dot count x. Mm, I think we have to pass here values underscore count. Now let's run this. Okay. Here you can see this is the class wise data distribution of our news data. So the zeroth level, that is means the zeroth class contain around 10,000 data, or class 1 contain around 7,000. We have already seen this, but just for visualization part, I am going to I have like created a bar graph of this. Let's add another column which can explore about how many characters present in the respective news. Okay, so let's add another column, data of news underscore size. This is the column name. So let's create it, data of text, and here we have to perform apply operation. We are going to apply length operation. Now again load our data set. Okay, here you can see the new column get added to our data set. This is the news size column. So first news, this is the news, contains around 4,930 characters. The second news contains around 4,160 characters. Let's see how many, if zeroth label news contains higher character, or class 1 label contains higher characters, means like real news having higher characters or fake news having higher characters. For that we are going to draw a kernel density estimation curve. So let's write it here, um, distribution of characters. Okay, first of all let's define the figure size, plt dot figure. Inside this we are going to pass fig size, which is let's say 10:5. Again we are going to use sns library, sns dot, we are going to use the function kde plot. Let's pass our data, that is news size. For that we are going to write data of label equals to 1. Then here I have to pass news underscore size. It will fetch the news underscore size which having label 1. Okay, let's pass color equals to sky blue. Again we are going to label this as a label 1, label hyphen 1, and this is the sufficient arguments. Now let's copy this actually, because we have to just change color and the class label. This is the 0, class label is label 0, and write it here salmon. Okay, again let's define the title, plt dot title, message size distribution. Okay, let's name it as a message size distribution. Let's define x label as a message size, or let's inside write the bracket with number of characters. Okay, let's define y label, plt dot y label. Here we have to write density. Again we have to pass plt dot legend. Again Let's write plt dot grid, and inside the bracket we have to pass true. Let's show the graph plt dot show. Let's run this. This is our KDE plot. So orange or salmon color is for class 0 and sky blue color for class 1. Okay. So here you can see the number of message size or number of characters which having the news having around 5,000 6,000 number of characters. That is this part only having higher density. Here you can see the density is quite high, but the news or the characters present in the news which is higher than 18,000. Here you can see this is a little bit of around 18,000. Okay, having low density. Here you can see this is the low density, and the middle message or middle part here you can see which having characters around 5,000 6,000 7,000 or around 10,000. It's having higher density. Here you can see this is the peak curve. It's about you can see the density is maximum about 0.00016. It's of around those messages having characters 5,000 to 10,000. So those messages having higher density means like we can say our data set contains higher number of message which having characters around range 5,000 to 10,000. Okay. Let's create another graph that is box plot to understand the data distribution of message size over the classes. Okay. So first of all, we are going to draw a figure size plt dot figure. Inside this, we have to pass fixed size, that is 10 as to 6. Again, we have to write data dot box plot. Inside this, we have to pass our column that is news underscore size, and the second argument is by means label. We are going to create a distribution of news size by label. Again, we are going to pass grid equals to true. Let's name our graph plt dot title as a news size distribution. Let's say distribution. Okay. On the x-axis we have label plt dot x label. Let's name it as a label. And on y-axis we have message size plt dot y label. Let's write it message size, or we can say in bracket number of characters. Let's write plt dot show. Let's run this. This is our box plot. Okay, so here you can see this is the interquartile range. From this black line to this black line. This is the interquartile range, and you can see most of the message belongs to this part. Okay, it's around, as I said, 0 to around 10,000. Most of the message belongs to 0 to 10,000, and these black dots are actually the outliers. So the dots above this line are outliers. Here also you can see in case of label 1, these are the outliers. Label 1 has many outliers. Here you can see one of the outlier having characters more than 1,40,000. Okay, this is the that particular label we have which having higher characters. So let's check which having these many characters. Uh, let's write max of data of news size. Okay, there is one data point or one news which having 1,42,961 characters. Okay, so this is I think that point. These are the outliers. Black dot are the outliers, and this is the major part of our news. We can say major news belongs to this particular region. It's around 0 to 10,000 or 11,000 around. We can say approximately 10,000 or 11,000. So I think the number of characters belongs to label 1. News The news belongs to label 1 having higher characters because it's having some outlier values also. But more or less we can say the both news having same number of characters, which mostly around 0 to 10,000. Okay, or we can say as I said in the KD graph, it's mostly around 5,000 to 10,000. We can say also 0 to 10,000. That is the better prediction or better understanding. Okay, so lastly the result is most of the news belongs to the both the labels, that is 0 and 1, having characters around 0 to 10,000 or 11,000. So this is all about exploratory data analysis. With exploratory data analysis we can able to understand both the news having similar number of characters, most of the news having similar number of characters, and some of them having outliers as well. Okay, so this is all about exploratory data analysis. And as we can see here, zeroth level having higher number of news, or we can say the number of news belongs to the real class or real news are quite higher in number as compared to the one class or one level. One is we can say unrealistic news or fake news. Okay, so this is all about exploratory data analysis. Now let's move on to the another very important step, that is data cleaning. Every model requires a clean data. So in case of text, we are going to perform text preprocessing. Preprocessing. We required code snippets. So let's remove this markdown. Now let's import the required libraries for text cleaning. Import NLTK, which is Natural Language Toolkit. Another is from NLTK, nltk.corpus. We are going to import stopwords. Third is from nltk.stream. We are going to import wordnet limitizer. Fourth is from nltk.tokenize. We are going to import word underscore tokenize. And lastly, we are going to import regex library. So let's run this from import re. Okay, import re. So let's run this. Now we are going to define a function that is going to clean the whole text. Okay, define a function clean underscore text. Inside this we are going to pass our text, that is text string. So in text cleaning we are going to perform first step, that is lowering the text. Lower the text. So for that I am going to write text equals to text dot lower. It will lower down the whole text or convert the whole text into a lowercase. Second step is remove the punctuation. Non-alphanumeric characters, and also remove the white spaces. Okay, for that I am going to write text equals to re dot substitute. Here I am going to use regex library. So I have to write r. Again I have to pass a string. The string we start with we can say non-alphanumeric characters, or the string contains a non-alphanumeric characters. So here I have to write, okay, for that I have to write w and again slash of s. It will remove the non-alphanumeric characters as well as also removing the white spaces. This yes is for removing the white spaces. White spaces include tabs, new lines, tabs and spaces. Okay, and the slash w will remove the non-alphanumeric characters and also remove going to punctuation marks as well. Okay, now let's move on to the third step, that is tokenization. Tokenization. For that, I have to write tokens equals to word underscore tokenize. Inside this, I have to pass text. The third, fourth step is like removing the stop words. Stop words. Okay. So firstly, we have to like list the stop words. So for that, I'm going to write stop underscore words equals to set of stop words dot words, and again I have to pass English here. So we are going to call the whole list of stop words English stop words. Again we have to write tokens equals to the token for token in tokens if token not in stop words. Okay, stop underscore words. Ideally we are going to remove the stop words here. We are going to write if the tokens belongs to this tokens list but not belongs to the stop words. Okay, we are going to list the whole tokens which are belongs to this token list but not belongs to the stop words. So ideally we are going to remove the stop words from our tokens. Now the fifth step, we can say limitization. Limitization. Okay, so for that I am going to import limitizer. Limitizer equals to wordnet limitizer. Okay, so I am going to write tokens equals to limitizer dot limitize the tokens for, let's say, token for token in tokens. Okay, it will limitize the whole word, we can say. Limitation means like let's say there is a word jump, jumps. So the basic word is, or the meaning of jumps is like, basic meaning is jump. So it will remove the yes part and it will only return the jump. Okay, this is an example for limitation. Again we are going to join the tokens, clean text, ideally joining the tokens. So we can say cleaned text, clean underscore text, which equals to, we are going to join it with uh, we are going to join these tokens. Okay, and this function will return the cleaned text. Clean, let's say cleaned text. Okay, so this is the function which will quite helpful to clean our whole text. Okay, now let's check this function working well or not. For that I am going to write a sentence equals to the cats moving around the house and the dogs are sleeping on the porch. Okay, also I am going to pass the exclamation mark and the new line character. Okay, so let's run this. I wanted to clean this text, so I'm going to pass this sentence to this clean underscore text function. So let's write clean underscore sentence equals to clean underscore text. I'm going to pass this sentence to this function, clean underscore text function. So let's copy this and paste it here. Let's print clean underscore sentence. Let's run this. Okay, here you can see, okay, this is not the port, this is porch. Okay, let's run this again. We Here you can see the exclamation mark as well as new line character also get removed from here. uh, the cats will get converted into a cat because with the help of limitizer, the cat's part, yes part is getting removed and only the cat part is remaining. Also the stop words like the and are, on, again the, these are the stop words. This also getting removed with the help of our function. So from this we are able to know our function is quite working well. Okay, one thing I wanted to tell you, you have to download the NLTK data repo from NLTK toolkit. Okay, so make sure that you have downloaded this data repo from NLTK toolkit. For that you have to write NLTK dot download. I have already downloaded this, but I wanted to tell you, for that I am going to write this. Inside this we have to pass stop words. Okay, here I have to write NLTK. Okay, the second is NLTK dot download. We have to write wordnet. Third is NLTK dot download punkt. Okay, this is the string. Okay, this data repo, that is stop words, is helpful to running the functionality of stop words. This will be helpful in this case, like calling the stop words. Second is wordnet. Wordnet is quite helpful for wordnet limitizer. So if you haven't downloaded this data repo, that is wordnet data repo, then you might get an error while running this wordnet limitizer. Again, punkt is required for word underscore tokenize. If you haven't downloaded this data repo on your machine, then I will definitely get an error while running this word underscore tokenize as well as limitizer. Again, in case of stop words, we will get also get some error as well. So make sure you have downloaded this data repo. So for that you have to use this commands or code line. Now let's clean the text present in our dataset. Text means the news. Okay, so let's check how many news present in our data. Data of text, we have text column consist of news. So let's run this. We have around 18,285 entries in the text column. That is, uh, we have 18,285 news. Okay, fake and real news. So let's clean this text. For that, I'm going to write data of text equals to data of text. I'm going to use apply operation. Apply this clean underscore text function. So I'm going to pass this clean underscore text function to this. Okay, so let's run this. It will take some time because we have around 18,285 entries or 85 news. So we are going to perform all these operation on each and every entry, or each and every text belongs to this text column. So it will take little bit amount of time, maybe around 50 or 50 to 60 seconds or around 1 minute. Okay, here we are done with our text cleaning part. Now let's move on to the next step, that is model building part. But before that, let's load our dataset. Data dot head. So this is our text column which we are going to use to train our model. Okay, so the text belongs to this text column is a clean text because we have already performed text cleaning with the help of clean underscore text function. Now let's mark down our next step, that is model building. LSTM model. We are going to create an custom LSTM model. So Firstly, let's import the required libraries to train our data. Import. So I have to open a code snippet. So this is the markdown snippet, so I have to delete this. Okay, let's import numpy as np. The second package is from sklearn dot model underscore selection. We are going to import train underscore test underscore split. Third is from tensorflow dot keras dot preprocessing dot text. We are going to import tokenizer. Another is from tensorflow dot keras dot preprocessing dot uh, dot sequence. We are going to import pad underscore sequence, and again from sklearn dot metrics we are going to import accuracy underscore score, and again classification report. Okay, classification report. These are the basic required libraries that we require to train our model. Okay, so I am using tensorflow 2.10. I will show it. Okay, import tensorflow as tf. So let's see the version, tf dot underscore underscore version. So I am using 2.10 version. So these are the compatible imports for 2.10 version. Okay. So if you are using another version of TensorFlow, then you may get an error. So make sure that you have 2.10 installed in your Python. Okay. TensorFlow 2.10 installed. Okay. Now let's move forward. Firstly, we convert our text data into numerical format to train our model. Okay. So for that, I'm going to write tokenizer equals to tokenizer. I have already imported tokenizer from TensorFlow. Here you can see. Okay. Let's feed this tokenizer to convert our text data into numerical format. So I am going to write tokenizer dot fit on text, that is data of text. Data of text consists of all the entries of news. Okay, let's write x equals to tokenizer dot fit on sequences. Okay, it's not a fit on sequences, it's on text to sequences. Okay, we are going to convert our text data into a number format, and this text should be in sequential manner. Okay, I will show you. Okay, let's run this. It will take little bit amount of time. Okay, but meantime you can like next code. Tokenizer is actually assign an index to each unique word within our text. Okay, so let's write index word. So you can see each word having its unique value, unique index, we can say. Said having unique index 1, Mr having unique index 2, Trump having unique index 3, and so on. So let's check how many unique words present in our text. We can say this is our vocabulary size. We can say we have around 1,76,121 unique words in our data. Okay, let's print this x so you can able to understand how our numerical data looks like. Uh, okay, this is the data. You can see it's just a sequence of this particular index. We can say uh, let's do some post process to on this our sequence. We are going to convert this sequence is in a uniform length. Okay, so for that I am going to write max length. First of all, let's uh, clear this output. Okay, uh, I am going to define max length equals to 50. 50 is the length of each sequence of our data. or numerical data, we can say. Capital X equals to, I am going to perform padding on each sequence, pad underscore sequences. Inside this, we have to pass this X. X is our numerical data. You can see this is our data. Again, we have to write padding equals to pre. Again, lastly, max length equals to max length. So what this pad underscore sequences function does, it will truncate all the sequences which having length greater than 50. Okay, we are not going to use the sequences which having length greater than 50. We are going to use only those sequences which having length less than 50. And if that particular sequence having length less than 50, like 48, 45, then we'll apply padding on that particular sequence to make it 50. Okay, we are going to adding some zeros at the starting of that particular sequence to make this particular sequence to length 50, of length 50. Okay, so let's print X. Okay, I'm going to show one entry of this X. So this is the sequence. Okay, one sequence of our data. Let's check the length of our numerical data. You can see we have 18,285 entries in our data, numerical data. So let's check length of our data text column. Okay, so you can see here each entry within the text column converted into a numerical format, because you can see the length of this X, that is numerical data, and text data having same length. Okay, 18,285. So each entry within the text column converted into a numerical format, and this entry is actually in a sequential format. Okay, this is the sequence. Okay, this sequence is helpful to build an LSTM model. That's why this is in a sequential manner. Okay, I will explain this in another way. Okay, let's fetch the first entry of our text column. Okay, here you can see the first word of this entry is house, and its index number is 182. Second word is dame, and its index number is 212. Aid having index number 1103. So each word having its unique index number. So ideally, we have around 1,76,121 unique words within our vocabulary, and each having its unique index number. And the sequence is all about index number of the respective word within the text. Okay, so ideally this text is mapped with this sequence. So this is all about converting text data into a numerical format. Now we are going to use this numerical data to train our LSTM model. Let's move further to train our model. So before moving for training, we have to split our data set into training and testing set. So let's define our target variable, that is label. Okay, let's define training set, that is x underscore train, x underscore test, comma y underscore train, comma y underscore test, which equals to train test split. Inside this, we have to pass our data as well as label, that is x and y. Again, we have to define test size, which is 0.2, and random state 20. So ideally, 80% data set is belong to the training set, and 20% of the data set belongs to the testing set. So let's run this. Okay, now our data set is split into two parts, that is training set and testing set. Now let's define custom LSTM model. This is very important and crucial part of our model or project. So custom LSTM model. For this we require some libraries from TensorFlow dot keras dot models. We have to import sequential. This is the class, sequential class. Again from TensorFlow dot keras dot layers, we have to import embeddings. Again LSTM and dense. So these are the layers which is present which we are going to add in our custom LSTM model. So let's initialize a class, sequential class. But before that, we have to define a vocabulary size. Vocabulary size equals to a length of tokenizer dot word underscore index plus 1. Okay, let's define our model equals to, let's initialize the sequential class. Okay, now we're gonna add model dot add. This is the first operation, embeddings. Inside this we have to pass vocabulary size. Again, the input size we can say, which is 40, and input length, which is the input underscore length, which equals to max length. Okay, this is the first layer. Again, we are going to add another layer, model dot add. This is the LSTM layer. Inside this we have to define number of units. I'm going to define 150 units of LSTM cell. These are the LSTM cell units. So again we are going to add another layer, which is dense layer. This is very small and small model actually, which having around 3 to 4 layers. Inside this we have to pass number of units, which is 1. Again, activation would be activation equals to, let's say sigmoid, because we are going to classify it into two classes, 0 and 1. 0 is the real news and 1 is the fake news. Again, we are going to compile our model dot compile. Inside this we have to pass loss equals to binary underscore cross entropy. Okay, we have to define our optimizer, that is Adam. Again, we have to define matrix, which equals to accuracy. Okay, so lastly we are going to print our model summary, model dot summary. So this is the whole model. This is very small model, but it will definitely work well for us. So let's see. So I'm going to train our data on this model, but before that I will explain it again. First of all, we have initialized a sequential class. Again, we have added embedding layer. Again, LSTM operation with a number of cells 150. Again, there is a dense layer with activation function sigmoid. Again, we are going to compile our model with the help of loss function, binary cross entropy, optimizer, Adam, matrix, accuracy. So let's run this. Okay, this is the model summary you can see here. Let's move further to train our model. So let's train model. So for that we have to fit our model on x train and y train. X underscore train comma y underscore train. Again, we have to define number of epochs, which would be 5. Batch size, which is 32. Again, we have to define validation data, which is x underscore test comma y underscore test. So let's run this. It will take some time because we have around 18,000 data. So as per me, I think it would be 15,000 in a training part. So it will take a little bit time. Here we are done with our model training. Now let's take an inference on the testing data. We have already passed our testing data to the validation part, but still we are going to calculate probability or the precision and recall for each class. So for that I am going to take an inference on the testing data. So let's write y underscore pred equals to model dot predict x underscore test. It will take an inference on the testing part, that is test data. Again, it will return probability. Okay, here you can see this is the probability. So if the probability is greater than 0.5, then it will be classified as a 1, and if it is less than 0.5, then it will be classified as a 0. 0 is nothing but real news. Here you can see we have two classes, that is real and fake. If the particular label is 0, then it will be classified as a real, and if the particular label is 1, then it will be classified as a fake. So if the probability is less than 0.5, then it will be classified as a true news or real news, and if it is greater than 0.5, then it will be classified as a fake news. So we have to round up these probabilities. Y underscore pred equals to np dot round. Inside this we have to pass y underscore pred. Again, let's print the accuracy underscore score, which is inside this we have to pass y underscore test comma capital Y underscore pred. Again, let's print the classification report. Inside this we have to pass same argument, which is y underscore test comma capital Y underscore pred. So let's run this. Here you can see we have accuracy about 90%, and also you can see here the zeroth class having about 92% or 0.92 F1 score, and in case of label 1 it's about 0.89, which is quite good. So our model accuracy is quite well, so we can proceed further with this model. So let's save our model. I am going to save this model in H5 format. So let's write the name of this model, LSTM underscore model dot H5. So let's run this. Here you can see our model is saved in the same directory, LSTM underscore model dot H5. Now let's move on to the deployment part. We are going to deploy this model with the help of some backend API. So first of all, let's create one file, that is backend.py. Inside this, we are going to import some basic libraries that we required for our model deployment with some backend API. From class, we are going to import JSONify. Again, we require request. Again, we are going to import Flask. Another library is from TensorFlow dot keras dot preprocessing. We are going to import preprocessing dot text. We are going to import tokenizer. Again, from TensorFlow dot keras dot preprocessing dot sequence, we are going to import pad underscore sequence. Again, from TensorFlow dot keras dot models, we are going to import load underscore model. And lastly, we are going to import numpy as np. So these are the required library or basic libraries that we require to deploy our model with some backend API. So again, we required our text cleaning function. So let's copy this from here. We have already created this function. So these are the required libraries for our text cleaning function. So let's copy this also. Okay, and paste it here. Now let's copy the function, that is clean underscore text function, and paste it here. Okay, So these are the required things that we need to deploy our backend API with this LSTM model. Now I am going to initiate this app, which equals to Flask, and inside this I have to write underscore underscore name. Okay, this will initiate the Flask class, so it will be helpful to write an API and run this app. Now let's load our model. So let's write loaded model, which equals to load underscore model. Inside this we have to write the name of model, LSTM underscore model dot h5. Again, we have already defined a sequence, that is max length. We have already defined here uh, where it is. Let's see. We have defined max length, which is 50. So maximum sequence length is 50. So let's write max underscore sequence length, which equals to 50. Again, there is a some type of mistake. This is TensorFlow. Okay. From TensorFlow.keras.models, we are going to import load underscore model. Now let's move on to the next part, that is write an backend API or backend endpoint uh, to take an inference on the news. So let's write app.route. Here I am going to pass the endpoint name, that is /predict. Again, we have to define methods equals to, this is the post API, because we are going to pass a news as an input to this backend API. So let's define a function, that is predict. Okay, so input coming from front end is passed to this API. This is the post request, and this API will pre-process the whole text and return a response, that is this particular news is fake or real. Okay, this is the response of this backend, this API endpoint. Okay, so let's first of all import or load the JSON data coming towards this API. So for that I am going to write request dot JSON. Again, the data is nothing but JSON underscore data, because the input data coming towards this API is in a key value pair. So we are going to define key of that particular news is news. Okay, so we have key value pair. The key is news and the value is actual news or a text. Okay, so let's move forward. First of all, we are going to clean this data. So new underscore data equals to uh, clean underscore text. Inside this, we are going to pass this data. We are going to clean this data with the help of this clean underscore text function. Okay. Uh, Now let's move forward. First of all, load our tokenizer, which equals to tokenizer. We have already imported it here. Here you can see tokenizer. I think there is a mistake from pre-processing sequence. I have to import pad underscore sequences. Okay, pad underscore sequences, right? Now let's apply this token, or we can say tokenizer dot fit on text. Inside this I am going to pass the new data. Again, we have to create a sequence of each text. So for that I am going to write sequence equals to tokenizer dot text underscore to underscore sequences. Okay, so let's pass the new data in the list format. Okay, so keep in mind here you have to pass new data in a list format. Again, let's perform padding to convert each sequence into a uniform length of 50. Let's write padded underscore sequence, which equals to pad underscore sequences, and inside this we have to pass our sequence first of all. Again define padding, which equals to pre. Again max length, which equals to max underscore sequence underscore length. We have already defined it here. Here you can see it is 50. This is the length. Okay. Now let's perform prediction, which equals to, let's copy it, the model name. We have stored this model in this variable loaded underscore variable. So let's copy this and paste it here. So loaded underscore model dot predict, and inside this we have to pass padded sequence. Okay, so this will return a probability of that particular class. Now let's convert this particular probability into a label. Okay, if this particular probability is greater than 0.5, then it will be classified as a 1, and if it is less than 0.5, then it will be classified as a 0. 0 is ideally real news and 1 is ideally fake news. So let's convert it into a binary prediction. So let's write np dot round. Inside this we have to pass prediction. Okay, so this will return a label, means the actual output. So let's write response, which equals to response of this backend API. So response is, it's a prediction we can say, and its value is the actual binary prediction. It's an int value, so I have written it here, int binary prediction. So let's return this response, return JSONify this response. Okay, this is the backend API that we are going to use to perform inference on the news. To run this app, we have to write its host and port. So let's write if underscore name equals to underscore main. Inside this, we have to write app dot run. Again, here we have to pass host, which equals to, ideally it's a localhost 0.0.0. Okay. Again, the port is, let's define it as a 6000, and let's write debug equals to true. With the help of this debug argument, if we are going to change anything in this file, that it will automatically load the whole app. Okay, so we no need to restart the app, it will automatically load the whole app. Okay, so I think there is a mistake. You have to write double equal to. Now it's fine. Okay, we can save this file. We are done with our backend part. Now let's move on to the front end part. Let's create a file, that is front end. We are going to create front end in a Python. Front end, it's a typo mistake. Front end.py. So we required a basic library, that is Streamlit. Import Streamlit as st. Another required library is request. Okay, let's define a function, that is main function. Inside this, firstly let's define title of our app. Title, let's define title as a fake news classification app. Okay, now we are going for reading the input. User underscore input equals to st dot text underscore area. Let's write it here, enter the news text. Okay, so this is the input. Again, the actual data is data equals to, let's define a dict, and its key is news. Okay, this news key actually we are going to use it here. We are going to read a news key, and its value is actual news. This is the user input. It is the value of the news, a value of that particular news key actually. So let's write it here, user input. Now let's create a button. If st dot button, inside this we have to define the button name. Let's define button name as a classifier. Again, another condition is if user underscore input, then we have to write we have to hit that particular backend response equals to request dot post, and inside this we have to write an endpoint name, http colon slash slash localhost, or you can also define 0.0.0.0. Let's define the endpoint name, that is predict, and it's uh, actually we have to define port also. The port is 6000, and for this API we are going to pass JSON data, JSON underscore data equals to data. Now let's read this response. It's not a JSON underscore data, it's a JSON. Okay, so let's read the response. If the response is success, response dot if response dot status underscore code equals to 200, then let's read this response. Prediction equals to response dot JSON, and inside this we have to pass the key name. The key name is actually prediction. So let's copy this key name. This is the response. This is the response we have written in the backend file. So let's copy it and paste it here. Okay. Again, the prediction is a number form, that is label. So let's convert it into a text. If prediction equals to 0, if the label is 0, then the prediction, final prediction, let's say final underscore prediction equals to real news, because if the particular label is 0, then it's a real news again. And in the else part we have to write it's a fake news. Final underscore prediction equals to fake news. Okay, now let's write the success response to the app. st dot success, we have to write string, the news is here we have to define the final prediction. Okay, we are going to create a string as a success to our app, success response to our app, and if it fails, if the response code is not 200, then it will return else st dot error. It is also a string error while making prediction. Okay, so this is our app. We have to run this app. For that I am going to write if underscore name equals to underscore main. Inside this if condition we have to write our main function, so it will run this main function. Okay, this is the front end part. Now let's move on to the last part, that is deployment part. First of all, we are going to deploy the back end, and after that we are going to deploy front end. Okay, so before going for a deployment, let's check our file. Is it our code is okay or not? Is there any minor mistake or not? So first of all, let's go through. We have imported libraries, and again user input passed to the uh, response as a data. I think this is not the text area. It should be a text underscore input. Okay, let's change this. It should be text underscore input. Make sure that you have also changed text underscore area as a text underscore input. And let's save this. And remaining part, the prediction, real news, and success. And if not get an status code 200, it will show an error. Okay, it's fine. Now let's move on to the backend.py. So we have imported all the libraries, required libraries. I think in the importing we did some mistake. It's a key. It's not a keys. It's a keras. I have a typo mistake here. Let's say it's not a keys. It's a keras. Let's change it. It's a keras. It's also a keras. So by mistake I have written it as a keys. Okay, it's a typo mistake. Again, we have written the clean underscore text function, loaded the model, defining the maximum sequence length. Okay, again there is a mistake. Okay, you have to write at the rate app.route. Okay, while defining the endpoint, you have to write at the rate app.route in the flask. Okay, it will not work. Otherwise, it will definitely not work. So you have to write at the rate. So make sure that you also change all these things. First of all, I did mistake in the keras. It's a typo mistake. So make sure that you also change. Okay, so let's save this and run our app. Okay, I wanted to use Python 3.10 environment. So let's change it. Conda activate Python 3.10. Okay. Let's run backend.py file. Python backend.py. Okay, it will take little bit amount of time. Meanwhile, let's open another terminal where we are going to run our Streamlit app. Here you can see our app is running properly. Backend.py app is running properly. It running on 6000 port. Here you can see we have successfully deployed our backend. Here you can see it's running on 6000 port. It's successfully running on 6000 port. Now let's open another terminal. Also activate conda environment Python 3.10. Conda activate Python 3.10. I am going to run our front end, that is Streamlit app here. So let's run it. For running Streamlit app, you have to write Streamlit run and your file name frontend.py. So let's run this. Okay, I think it's working fine. So let's check. It's a good. It's a big news. Okay, let's check what will happen. Classified. Mm, okay, it's saying error while making prediction. Okay, let's check. There is no error in front end. There is an error, I think, in the back end. Okay, the error is tokenizer object has no attribute text underscore to underscore sequences. Okay, I got it. Uh, in the backend part, here you can see in the tokenizer part, you have to write text underscore to underscore sequences. I have missed this. Yes. So you have to write text underscore to underscore sequences. Now let's save this. We have already write it as a text underscore to underscore sequences. You have to change it and write it as like text underscore to underscore sequences. Just there is a change in this yes part. Okay, only minute change. So let's save this. It will reload again because we have already provided debug equals to true. It will automatically adapt the change and reload the file. Okay, now let's go on the UI part. Let's check is it working properly or not. This time it should work. Okay, it's a fake news. It is saying it's a fake news. Now let's see, we have another file that is test.csv. let's load it uh, let's load it in our fake news. uh, file. So import pandas as pd. Okay, so let's run this. We are going to open this test underscore data, which equals to read underscore pd dot read underscore csv. We are going to take some news out of from the test .csv. Test.csv. My test.csv in the same directory, so it will automatically get it. So let's run this. Let's uh, let's load our data. First of all, test underscore data dot head. Okay, so this is the data. Text is actually consist of news, fake or real news. They haven't provided actual labels, they just provided news. So let's take one news out of this text column. um, text underscore test underscore data of text. Let's take of one index one news. So ideally this is the news: Russian warship ready to strike. Okay, so let's run this. So this is the news. Let's copy it. Let's copy it and paste it here. Okay, this is the news. Let's see what will happen this time. What will it will say? It will say fake news. It's also fake news. Okay, let's take another news. Okay, let's zero news, or let's say 15th. Let's run this. So let's copy it and paste it here. First of all, let's remove this and paste the another news, and let's classify it. It also says it's a fake news. Now let's write a random news. The election will be in the next year. Let's see what will happen. It will take little bit amount of time to inference. Okay, it is saying this is a real news. Okay, sometimes our model says it is a fake news, and sometimes it is says it's a real news. So accuracy may vary from, let's say, your model and my model. Depends on the parameters as well. So there are many things that will impact the model accuracy. Okay, so you can also perform parameter tuning to optimize your model as well. So thank you for watching. If you enjoyed the video, please subscribe my YouTube channel. See you in the next exciting video.